Now is your AFLP. AFLP is your amplified fragment length polymorphism, and it depends upon, again we use restriction enzymes, but we use PCR as well to amplify specific bands in this. Okay? So AFLP is considered as a dominant marker. एंड इसमें क्या होता है, एक कंसेप्ट ऑफ समझ लीजिए, दैट्स वी यूज टू रिस्ट्रिक्शन एंजाइम्स टू कट ओवर डीएनए. ओके, अगेन इस केस में दो ऑर्गेनिजम्स हैं, से फॉर एग्जांपल एक ये है और एक ये है. ओके, वी यूज टू रिस्ट्रिक्शन एंजाइम्स. वन इज कॉल्ड योर रेयर कटर, and another one is called as a frequent cutter. So rare cutter cuts rarely and frequent cutter cuts frequently. What does it mean? As we know, we have studied restriction enzymes, we know that what is the probability that a restriction site, a restriction enzyme will cut in a DNA will be dependent upon 4 to the n. 4 is your ATGC, 4 bases, and n is your recognition sequence of your restriction enzymes. For example, there is a 4 cutter, AATT is a recognition sequence, and this restriction enzyme, say any restriction enzyme X, recognizes 4 base pairs. So that means this will be equal to 4 to the power 4 equal to 16 into 16. You can do the math कि कितना होता है. Okay. Now, for example, this will be called as a frequent cutter. Why? I'll say that. I'll tell you that. For example, this is equal to 256. That means, for example, if there is a DNA stretch, if it cuts here, it will again cut after 256 base pairs. So this is a 1000 base pairs fragment. Again, it will cut at 256. Again after 256, it will cut again. Again after 256, it will cut again. So it will cut around, say, 4 times in your 1000 base pairs of DNA. Now, for example, you have a rear cutter. For example, GAA PTC. So this has a 6 base pair recognition. So this will be 4 to the power 6, 4096. So in this fragment, if it cuts, here, it will not be able to cut again in that DNA, because now its probability of having the same restriction sequence in this DNA of 1000 base pairs will come after 4096 base pairs. However, ये आपका 1000 base pair का ही है, this sequence इसमें एक ही बार होगी. तो आप, you understood what is the difference between frequent cutter and rear cutter. We use both these enzymes to cut our DNA. Now, for example, इसमें frequent cutter ने, we'll use another color. We have a lot of colors. So say frequent cutter will cut here 1. Say frequent cutter will cut here 2. Frequent cutter will cut here 3. Frequent cutter will cut here 4. Sorry. Frequent cutter will here. Okay, let's take off. And now if you cut again with a rear cutter, so rear cutter will cut here, rear cutter will cut here. So the difference you saw, the frequent cutter will cut again and again because the probability of having a frequent cutter restoration recognition sequence will come again and again, say after 256 base pairs. In the other case, it will come after, say. So that's why you have more frequent cutters here and less rear cutters. So if you, now again, what will happen if there is a abolition of a recognition sequence? Okay. So in case 1, this was case 1, this is case 2. In this case, you have a, say, you have a frequent cutter here, say frequent cutter here, okay, say frequent cutter here, frequent cutter here, and the restriction site for this got abolished. Okay, you have a frequent cutter here, and frequent cutter here. Now if you talk about rear cutters, you have a rear cutter here, and this rear cutter site got abolished because there was a mutation and this enzyme will not be able to recognize it. Okay. Now after cutting this, we will draw it again. So you have, in case 1, you have one fragment like this, then you have another fragment like this, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Similarly, in this case, you will have 1, 2, 3, 4, 5, 6, and 7. Oops, sorry. And 7. No, in this case, we have 8 only. 1, 2, 3, 4, 5, 6, 7, 8. Sorry about that. Okay. Now, if we see which ends this have. So this has a frequent cutter end, and this side it also has a frequent cutter end. This has a frequent cutter end. So this end. So one will go to this end and one will go to this end. So since these two restriction enzymes make palindromic sequences that are complementary, so ये अगर काट गया यहाँ से भी सिर्फ frequent होगा, यहाँ से भी frequent होगा. Similarly यहाँ पर आपका rear cutter होगा. यहाँ पर rear cutter होगा, यहाँ पर भी rear cutter होगा. Okay, this end. Now you have a frequent cutter. Okay, now इसका ये end frequent cutter. Okay. So this end, then this end, then this end, then this end. Okay, then you have a frequent cutter here, and now you will have a rear cutter here. You have a rear cutter here. You will have a rear cutter here. You will have frequent. Frequent. Okay, so you will have restriction fragments that are generated that will have either frequent cutter and frequent cutter at both sides, or the frequent cutter and a rear cutter at one side, right? Similarly, in this case, you will have a frequent cutter here and a frequent cutter end here, a frequent cutter here, and frequent cutter here, frequent cutter here, frequent cutter here, frequent cutter here, frequent cutter here. These are all frequent cutters. And you will have a rear cutter here. Now what we do after this, cutting this, we use adapters. Adapters are nothing but they are your double-stranded DNA molecules that have again a recognition sequence at one end. So the adapters, we use two types. One that will have, say, a frequent cutter, and another one that will have a rear cutter. So for example, this we used EcoR1. GAAPTC, GAAPTC. This will cut like this, right? And some say XYZ, some sequence here. So if you now delete this portion, so you will have an, this is your adapter. This is your adapter now. This will be your adapter for one restriction enzyme, and similarly you have an adapter for a different sequence. So what's the fun here? If you are using EcoR1, so that EcoR1, it will be able to ligate to that EcoR1 end. So now you add two adapters. The frequent cutter adapter will bind to the frequent cutter end, where the frequent cutter has digested, and the rear cutter will bind at the end where the rear cutter has digested our DNA. So now, if I draw them in say different colors, maybe pink. So you have a frequent cutter here, 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 frequent cutter here. So this will be this will bind to the frequent cutter sequence. Similarly, in this case also, this will bind at the end where the frequent cutters have cut. Okay. Similarly, say for example, now the other enzyme is your rear cutter. So rear cutter will bind here and here. It will bind here and here, and it will bind here and here. So now what you did, you first digested both of your DNAs with the frequent cutter, rear cutter, both of them, and then what you did, you added adapters, and then you ligated the adapters. So you have to use ligase here to, so that these adapters are ligated, like we did in cloning. We used ligase to join two DNA molecules and form that phosphodiester bond again, which was earlier cut by your restriction enzyme. So you ligase here, so these adapters will bind to your. After this, so restriction digestion, then adapter ligation. After adapter ligation, we use two types of primers. We use a forward primer for a frequent cutter and a reverse primer for a rear cutter. F for F, R for R. You remember it like this. So a primer for forward primer for a frequent cutter and a reverse primer for a rear cutter. So that means what will happen when you run a PCR reaction, You will add the primers, you will add DNTPs, you know we have gone through PCR. So now what will happen, a DNA fragment will only amplify if you have a forward primer and a reverse primer. Okay. Now if this is a 3' end, this is a 5' end, so then you have a 3' end here and a 5' end here, because both the strands are anti-parallel. So now this forward will bind here, it will have a 5' here, and it will form another strand that will go in this direction, and it will have a 3' here, and in this strand you will have a reverse primer that is a always the replication occurs from 5' and 5', 3' direction. So you have a 5' here, the primer, and this will bring about the synthesis of your other strand. So 2 strands will make 4 strands. So 2 to the power n after n cycles. So after 30 cycles, you have around 1 billion copies of your DNA form. So that's what happens in the PCR. So similarly, we use the same thing here. हम क्या करेंगे, अब ये primer for example यहाँ पर bind हुआ forward इस direction में, okay. So consider this is a double-stranded DNA. So forward will bind in this direction, okay, and ये भी frequent cutter है, ठीक है, इसकी direction भी same है, तो ये वाला ऐसे bind होगा. Sorry. This forward will bind like this, okay. This forward will bind like this. This forward will bind like this. This 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 will bind like this, because we are using a forward primer for a. Similarly, same thing. The forward primer will bind like this, like this, like this, like this, like this. Okay, so your forward primer has bound. Now is the chance of your reverse primer. So the reverse primer will bind like this. Here it will bind like this. Okay, and in this case it will bind like this. 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 Okay, now see the direction of your primers. जो direction मैंने बनाई है उसी direction में amplification होगी जब forward primer और reverse primer will be facing each other. So that means that fragment will be amplified. अगर ये opposite direction में फेस कर रहे हैं तो वो एम्पलीफाई नहीं होगा, क्योंकि 5', 3' ऐसे है और ऐसे है तो वो एम्पलीफाई नहीं होगा, बिकॉज यू डोंट हैव अ टेम्पलेट देयर. बट अगर ऐसे है तो एम्पलीफाई होगा. अगर अब ऐसे है तो एक फ्रैगमेंट तो एक प्राइमर तो एम्पलीफाई करेगा, दूसरा नहीं करेगा, तो आपका स्ट्रैंड एम्पलीफाई नहीं होगा. सो नाउ इफ वी गो फर्दर, ओनली those bands will be amplified that has a forward primer for a frequent cutter adapter and a reverse primer for a rear cutter primer. So इस केस में ये फ्रैगमेंट एम्पलीफाई नहीं होगा, क्योंकि इसमें एक फॉरवर्ड प्राइमर तो एम्पलीफाई होगा लेकिन रिवर्स नहीं होगा. सो ये एम्पलीफाई नहीं होगा. ये इसमें फॉरवर्ड भी है, रिवर्स भी है, बोथ आर फेसिंग टुवर्ड्स ईच अदर, सो दिस फ्रैगमेंट विल बी एम्पलीफाइड. इसमें रिवर्स उस साइड से है और फॉरवर्ड इस साइड से है. सो इसका 5 प्राइम 3 प्राइम इस साइड है, इसका इस साइड है, तो ये फ्रैगमेंट भी एम्पलीफाई नहीं होगा. अगेन दिस हैज अ फॉरवर्ड एंड फॉरवर्ड, ये फॉरवर्ड तो करेगा यहाँ पे एम्पलीफाई, मगर रिवर्स प्राइमर एम्पलीफाई नहीं होगा, तो एक ही स्टैंड एम्पलीफाई होगा, तो वो एम्पलीफिकेशन नहीं होगी, तो ये भी नहीं होगा एम्पलीफाई. इसमें अगेन यू हैव अ फॉरवर्ड प्राइमर this direction and the reverse primer this direction, this one will be amplified. इसमें again no amplification, इसमें no amplification, no amplification. So कितने बैंड आपको मिले? If you run this on a gel, you have 1 and a 2. आपको एक बैंड और दो बैंड मिले in organism 1. अब इस केस में again you have forward, this will not amplify. Forward, reverse, okay, this will amplify because forward and reverse are facing each other. This will not amplify, this will not amplify, this will not, this will not. So only a one band got amplified. Okay. Now you see the difference in your banding pattern. Now your banding pattern is different. किस वजह से? क्योंकि एक restriction site abolish हो गई या बन गई, whatever हो गया, जिसकी वजह से amplification नहीं हुआ उसका, और due to that reason now you have a difference in the banding pattern. So this is your amplified fragment length polymorphism, in which we restrict with two restriction enzymes for a frequent cutter and a rare cutter. Then we ligate adapters. Then we use primers specific to those adapters. क्योंकि हमें sequence पता नहीं थी इनकी क्या है जहाँ इसे काटा, मगर जब हमने adapters use किए, adapter की sequence हमें पता थी, because हमने वो डाले इसमें, तो हम उन primers को adapter के against ही बनाते हैं. So only then adapters will bind, but only those fragments will be amplified which have a frequent cutter and a rare cutter at the opposite ends. वही सिर्फ amplify होंगे. Okay. So this was about your AFL. We will stop here. So since this is not an interactive session, this is on AgriDiksha. I don't think they have that in which you can ask questions. So, but if you have any questions, you can put them on the group. So I'll be glad to answer that. And thank you so much for your patience. You guys have a great day. Bye.